Welcome. We are going to now start into linear equations or linear functions, which means we're going to talk about straight lines, a lot of straight lines, and we're going to learn how to write an equation of a straight line. Again, up to this point, all our equations, by the way, have been what we call a single variable equation. You know, we've been solving things like 3x plus 4 equals 10 or something, right? And we solve this two-step equation, but you'll notice there's only an x involved. Now we might actually have more terms with an x. We could have an x over here and a plus 9. And again, that's still just literally one variable in the expression. Now what we're going to be doing is we're going to be introducing the variable y, which is an outcome, equal to some x term, something times x, and usually there'll be plus some value over here. But the main thing I want to emphasize is it has both an x and a y value. It has both an x and a y, which are ordered pairs. Just like on this graph over here, we have ordered pairs. All linear equations or linear functions in terms of x and y have what we call a slope. And that's what we're going to introduce today or talk about is the slope of lines. Now, slopes are the ratio. A ratio is a fraction. And remember, integers can be fractions or considered fractions, they're just over 1. But the slope is a ratio of how much we rise or how much we go up or down versus how much we run or how much we go over from one point to another. So for instance, as I look at this graph, the most important thing about calculating slope is to make sure we use points that are easy to evaluate. You can use any 2 points on that line to find slope, but don't pick points that are in between grid lines on the graph. So what you do is you usually find a point. I'm going to pick this point right here that is where the vertical grid line at -40 meets the horizontal grid line at 10. So this here has a value or a coordinate of 40, 10. So I'm actually writing the coordinate down for that point that's right there. Then I look along the graph until I find the next nice intersection where a vertical line and a vertical axis grid line and a horizontal axis grid line intersect the actual line we're trying to find the slope of. And that's this point right here. So that point right there has a x value of 50 and a y value of 30. Now, what we want to do to find slope again, which is rise over run, is we want to ask ourselves, how much did I change vertically going from one point to the next? How much did I go up? And how much did I go over? Well, to go from a 10y value to a 30y value, I went up 20 units. To go from a 40x value to a 50x value, I went over 10 units. And so what we do when we write our slope is we write that rise of 20 over the run of 10. But then we always try to reduce or simplify that fraction. Again, they're both divisible by 10, so that's 2 over 1, or we actually just get a slope of 2. And so we type in 2. Okay, so now what I want to do is, let's see. Oh, I know how to do this. I'm going to do this. I believe it is, there we go. So here's another line. Again, what you will do is the first thing you're going to do is find the first nice point you can find. I like this point right here that has a x value of 0 and a y value of 3. Then I'm going to find this next nice point, which is right here, which has an x value of 1 and a y value of 6. And then I'm just going to ask myself, how much do I go up? How much do I go over? Well, I went up 3 and I went over 1. So my slope is 3 over 1, and that reduces to a simple 3. Not 2, 3. Okay, so I'm just going to continue to do that with each of these things. Now, again, remember, the points you use, make sure they're nice ones. Don't use this weird point in between 40 and 50. Go out here to where that, whoa, that was really weird. It moved on me. Out here to this point right here and this point right here. Now, when you start to do this yourselves, you'll obviously get a little easier and go, oh, I'm just going to go up and go over. And how much did I go up? Well, I went up 10 and I went over 20. Now you'll notice I'm actually using my scale out here. Watch your scale. That's going to be very important as you move into higher mathematics, that you watch your scale, because sometimes the scaling is different on the x and y axis. But for this one, my rise was 10, my run was 20, and again, that reduces to 1/2. So I come over here and I type in 1/2. Now, I believe every problem in here is going to have what we call a positive slope. Positive slope means I'm going uphill, going up from left to right. And I want to emphasize that all these slopes that we're dealing with, we're going up, going left to right. Eventually, we're going to start dealing with negative slopes that are going down. And a negative slope would have to have a negative value with it. But for today, I think all our slopes are positive. So here we have this value here. Ooh, that's not nice. Here's my next nice value. So I go up 20 and I go over 50. And so I get a rise of 20 over 50. But again, that reduces to 2 over 5. So I come over here, type in 2 over 5, and I get the right answer. Okay, I'm going to just skip ahead a little. Oh, I can't skip ahead a little bit on this one. So apparently all of these, like I said, are going to be positive slopes. I do want to emphasize that if you ever get a horizontal line, if you ever get a line that's perfectly horizontal, like this, then how much do I go up going from one point to another point? If I was to go up from this point here to this point here, I don't go up at all. I go up 0. But I do go over 3. And what is 0 over 3 reduced to? Well, it reduces to 0. So a horizontal line always has a slope of 0. Now, a vertical line is another slope that students get really confused at. If I have a vertical line, if you ever see a line that's perfectly vertical, I did that pretty good, and I take 2 points on there, then how much do I go up going from one point to the next point? To go up to there, I've went up 2, but then how much do I go over? I go over 0. Now remember, slope is rise over run. So I'd put that rise of 2 over a run of 0. And can I divide by 0? I cannot. That's called an undefined slope. Undefined. So the main thing I want to emphasize is if you get a slope that is slanted, that's supposed to be an N. If you get a slope that's slanted like the one that's actually on here, you'll get a integer or a fraction that's either positive if it's going uphill or negative if it's going down. But if you get a horizontal, your slope is 0. If you get a vertical, it would be considered undefined, and they would actually have to give you that option in the ability to submit on IXL. But I don't think you're going to see either 0 or undefined slopes today, and you're not going to see negative slopes, just these positive slopes. If you have any questions, please do feel free to ask me or send me an email, and I will help you as much as I can.